Hello everyone, myself Keshav Kumar Agarwal. In this project, I am going to demonstrate 7-segment display using 8051 microcontroller. 8051 microcontroller is also called as 8-bit microcontroller as it can perform arithmetical and logical operation on 8 bit of data in one cycle. There are 4 ports in 8051 microcontroller. This is port 0, port 1, port 2 and port 3. Each port having 8 input-output pins. This is XTL1 and XTL2 from which I have connected a crystal oscillator of frequency 11.0592 MHz along with two capacitor of 1 nanofarad each. This crystal oscillator provides constant clock to the 8051 microcontroller which drives the microcontroller. Here I have connected a 7-segment display to the port 3. This is a 7-segment display. There are 10 pins A, B, C, D, E, F, Z, DP. DP is the dot, and there are two other pins which are common. These are the 8 pins and 2 pins are commons. There are two versions of 7 segment. One is common cathode and one is common anode. This is common cathode type in which both the common terminal are connected to ground and all the LEDs are connected to ground also. To turn on a particular LED, we have to give logic 1 to the particular pins and other pins should be kept at 0. In common anode, the common pin is connected to the VDD or the plus 5 volt and all the other pins are also connected to the plus 5 volt. To turn on a particular LED, we have to give logic 0 and we should keep other LEDs to at logic 1. For example, when in common cathode, when we have to display 1, that means we have to turn on the LED B and C. So we will give logic 1 to B and C and all other pins should be kept at 0. Similarly, for displaying 2, we have to keep A, B, Z, E and D on and we have to turn off the LED F and C. Now, this is the pattern. First, I have to display 0, digit 0. For that, I have to turn on F, E, D, C, B, A and I have to turn off Z and DP. You can see from this figure. For displaying 0, I have to turn on A, B, C, D, E, F and I have to turn off Z and DP. That's what this is given. And this equivalent in hex value is given as 0, 3F. Similarly, to display 1, I have to turn on B and C and all rest others should be turned off. That's equivalent in hex value is 0, 6. Similarly, for displaying 2, hex value is 5B, for 3, 4F, and similarly all are given from 0 to 9. Now, this is the assembly language code for 8051 microcontroller. I have started from the location 00H. Now I have moved 3FH. This is for displaying 0. For displaying 0, I have to move 3FH in accumulator and this value stored in accumulator is transferred to port 3. Generate some delay. After that, again I value 06H in accumulator that corresponds to the displaying 1. Here you can see that corresponds to the displaying value 1. Here you can see 06 for displaying 1. After again I have moved the value stored in accumulator to port 3 that will display the value 1 on the 7 segment display. Again I have generated some delay. For now I have moved 5BH in accumulator for displaying 2. Similarly 4FH for displaying 3, 66H for displaying 4, 6DH for displaying 5, 7DH for displaying 6, 07H for displaying 7, 7FH for displaying 8 and 67H for displaying 9. And this is the function I have created for generating delay where I have used tmode function. Now I am going to simulate the project. For this you have to double click on the 8051 microcontroller. Now you have to attach the program file that is in the hex file written in the 8051 microcontroller. I've saved the file as 7 segment.hex. Open it. Okay. Now the simulation, you can see it is displaying 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and again it will display from 0 to 9. So it is working properly. That's all from this project. Thank you.